Okay, let's solve a problem on parallel access theorem. So what we have here is a disk, a solid disk, and this disk has a radius a and mass m. So we know, and this is the z-axis, and we know about the center of mass which passes through z-axis. The moment of inertia is going to be ma square over 2. So what we do next is that we cut out a hole or a circular hole from the disk, and the question is, what is going to be the new moment of inertia of this disk, the bigger disk, about the z-axis, where the hole we have cut out has a radius a over 4 and is the center of the smaller disk, the center of the hole is at a distance 3a over 4 from the z-axis. We can see 3 over 4 plus a over 4 gives you a only, so that makes sense. Okay, so how to solve this? So let's first of all let's see what can we do. Now this disk can be written or if what you can do is this disk plus, we can draw a line and something like this. This plus that is nothing but the total disk. Let's save time of drawing. This is the total disk. Okay, so we know that I of this, let's call this I bigger disk, plus I of smaller disk is going to be I COM, right? Because that's how center of mass that's how moment of inertia adds. Now, so we can calculate I bigger equals I COM minus IS. So all we have to do is calculate IS. So how to find IS? And IS is the moment of inertia of the smaller disk about the z-axis. So first of all, let's calculate the moment of inertia of the disk about its own center of mass. So let's call this ISCOM, which means smaller disk. And what is the moment of inertia about its COM? It's going to be again m, mass, what is the mass of the disk? Well, we have to calculate. Mass is a fraction, which is going to be the mass of the total disk, multiplied by pi a over 4 squared divided by pi a squared. You see, we have cut out a fraction of mass, so the mass will be a fraction of the original area, I mean the area of the smaller disk divided by the total area. So that is the mass of the smaller disk multiplied by the radius squared, and radius is a over 4, so that gives us a over 4 squared, and this is nothing but 1 over 16, 1 over 16, that gives us ma squared over 256. Okay, but this is about that. How to find IS? Now IS is going to be ISCOM plus m, mass of the disk, which we have already found to be m over 16, times this distance squared, right, which is going to be 9a squared over 16, and this is nothing but ma squared over 256 plus 9 ma squared over 256, and that gives us actually let's do it faster. So we get ma squared 5 over 128, and so IB is IB, let's call this is B means bigger disk, will be ma squared 123 over 128. I hope I haven't made any mistake, but if I have, please check the calculation. But the idea is simple. This is the idea which we are going to use.